This is going to be a quick overview on the general aspect of the walking analysis. All right, so here we look at the dashboard, and up top you can see that there's some patient information, as well as some of the control features that we'll cover in another segment. So here it shows us that we are evaluating a walk analysis. It gives you the details regarding the date and the time that you actually took this. We are going to be looking at the general aspect of this analysis here. So we see that there's a summary across the top, so you can actually either input some of this information when you're beginning the analysis, and you can always input it at a later time as well. The basic aspects of this include symmetry, cadence, and speed, real quick and easy to see across the top. You'll notice that there are color orientations. Green means that it's within the normative values of that specific demographic. And that means that the data that you input on the patient profile, including their age, gender, foot length, height, and weight, have influence as part of the aspects of the biomarkers, but also in the normative categories that we find that particular patient demographic. The symmetry characteristic is relative to the stance phase. So this is the amount of contact time during the stance phase between the right and the left foot. So that particular characteristic is showing us that there's a 96% symmetry. So there's only a 4% difference in the mean between time in the contact phase between the right and the left foot. And then we've got cadence, which is the number of steps per minute. So that's going to be relative to each step to the speed that we see here is at 2.0 miles per hour. We see that both of those are in red. And so take that into consideration, because red means it is outside what's considered to be the normal value for that particular demographic, for that particular patient. So what we see here is that 2.0 is considered to be slow. So for example, maybe the patient is experiencing pain. Maybe they just can't ambulate that fast for whatever reason, due to cardiovascular conditioning. Or they may have a fear of falling, for example. So things to take into consideration. Now, this particular analysis was actually performed on a treadmill, so the speed was set at 2.0 miles per hour, and that's one of the reasons we're seeing this more slowly. As we can scroll down, we see that the basic walking profile is presented in front of us, and it provides the stride length as well as the relative percentages during the stride of the stance and the swing phase, as well as the double support. So we can see here the left is oriented in this gold color, and we have a stride length of 46 inches. The right is the blue, and we see we have a stride length of 45 inches. And then we also look at the breakdown between the stance and the swing phase at 65.6, 34.4, and 64.7 and 35.3. On average, we see about a 60-40 split, give or take. And if we want to break that down even further, we can click on the advanced and continue to scroll down, and now we get more specific data. So the stride duration, again, relative to this particular demographic, is showing at the high end of the normal. In other words, it's taking longer to perform this particular overall stride. The stride length is on the short aspect. And again, remember that we were keeping this at 2.0 miles per hour because this was conducted on a treadmill. So the stride length is actually going to be controlled to some extent relative to the speed, especially when you're on a treadmill. When someone is walking over ground, we would actually want to take that into greater consideration because they have more control over it. So typically we would tell someone to walk with intent at a comfortable but brisk pace. And so they should have an appropriate stride length relative to the speed. But on a treadmill, this is going to be a little bit different. So we see that this is actually short. If it was short and it was over ground walking, some things to take into consideration again could be possible pain, possible fear of falling, for example. So we see in the older adult population that they won't take as long a stride length, and that they actually spend more time in contact with the ground and less time in the swing phase because you're actually going to be more stable. Also, you'll spend more ground contact time on one side versus the opposite side. So the opposite side, especially if we see that that is in the red on the short aspect, could be because of pain or limping. You don't want to spend a lot of time. Or if there's a weakness, could be longer contact time on that weak side because they don't have the ability to turn that step over quite as quickly. Scrolling down a little bit further, we see we have a gate line, and so the gate line is considered to be the center of pressure as we're moving through that stance phase, right? And it's broken down into loading, flat foot, and propulsion. So loading is going to be upon heel strike, and what we have shown and represented here in the percentage is the relative. So this is the percentage of time in the loading phase, the flat foot, and the propulsive phases. If you'd like, you can click on the absolute, and that's going to actually give you the time frame within that particular phase. We'll go back to relative, and again, you can look at either view depending on what it is that you're trying to accomplish. So we can see at heel strike, we're landing on just on the lateral aspect of the heel, which means that there's going to be a slightly inverted calcaneus. And as we go into foot flat position, we're going to transition, and typically what we see at the forefoot is going to be a pronation relative position. So we're going to be decreasing the amount of supination or decreasing the amount of calcaneal inversion, going into a neutral position, and then eventually we transfer that center of pressure as we're going through that stance phase over to the first and second ray for toe off. Next, we look at the propulsion rate. So the propulsion rate is the ratio of the amount of energy being contributed by the hip flexors and the plantar flexors. So that propulsion rate is late contact phase or toe off as we move into the swing phase where we've left the ground. So typically there's going to be a balance between those two groups of muscles to project the leg into the swing phase, so that way we're not doing too much off of the plantar flexors or too much off of the hip flexors. Oftentimes we see some changes, typically in the older adult population, as they attempt to maintain their normal speed rates. They compensate for weaker hip flexors by improving their strategies on the plantar flexors. Or maybe someone does not have good core stability, and therefore they're going to use a strategy of more plantar flexion than they would in hip flexion to create this propulsion rate. So we see that there's a percentage here and there's a coloration. So we see no coloration in the hip flexors, but we do see red coloration, and we see a 12%. So there's a lack of balance between the hip flexors and the plantar flexors, with an emphasis on the plantar flexors actually bilaterally in the right and the left.